Okay, and we are still on functions. And remember, we write functions as the f of x. All right. Oh, this board needs to be calibrated. Something awful. It's been a while. Okay. I will say the one thing that bugs me about writing on this board is my handwriting looks atrocious. I write so much neater on paper, but I get this right here is probably a lot easier for you guys to follow. So I'll just deal with it. It's okay. I'll get over it. All right. So today, what we're going to be focusing on is linear and nonlinear functions. This is the first part of the notes. Okay, linear and nonlinear functions. So there's two different parts, okay, to identifying something's linear and nonlinear. There's a graphing component to it, and then there's the equation component to it. And there's just a couple things that you have to look for. All right. So the first one that we're going to look at is we're going to focus on linear. Okay. So let's focus on linear first. Linear functions. A linear function as a graph, it's exactly what it says. Okay. It's a line. All right. So it's a line. So if you look at the word linear, you'll actually see the word line. Okay. Linear and line. You cannot spell linear without the word line. All right. So it is a straight line. Okay. A linear function is a straight line. So this is a straight line. No curves. All right. There's no curves. So if I was to graph that, it would look something like this. So if I sketch me a little graph here, all right, my linear function, assuming, okay, that's a straight line. All right, we'll just say it is. I know I can't draw a perfectly straight line. That function right there is linear. If I gave you this graph and I said, hey, is this linear? It's a straight line. You're good. It's linear. Okay. Another example. Okay. It's a straight line. It's linear. All right. You could also have vertical lines, horizontal lines. Um, they're linear functions. They're straight lines. They don't have any curves to them. Okay. No curves. So for linear, what's the equation look like? Okay. So the equation is fairly simple. Okay. I want you to write this in all caps and I want you to underline it. All right. No exponents. The equation has no exponents. Okay. On the variables, there are no exponents. So you might be like, hey, what do you mean, Mr. Reed? No exponents. Well, the equation will look like this. Y equals, say if I have y equals 4x plus 3. See any exponents there? No, there's no exponents. It's just y equals 4x. Okay? There's no exponent up here on the x. Okay? Y equals 4x plus 3. If I gave you that equation, I said, hey, is this linear or nonlinear? You're looking straight for the exponents. Okay? It doesn't have any exponents, therefore, that function is linear. Okay? So straight line, no exponents. All right? Pretty simple for linear. Okay? So let's look at nonlinear. So nonlinear functions. So what do we know about a nonlinear function? Well, pretty much the opposite of linear. Linear, the word non means it's not going to be that. All right. So this is going to have curves. Okay. This will have curves. So what's that going to look like as a graph? If I was to graph a nonlinear function, it looks like this. This will be an example. Okay, this has a curve in it. All right, this graph is curved, therefore it's nonlinear. I have this graph. Well, let's draw that in orange that way, like I did on the other one. Got a little ahead of myself. Okay, this is nonlinear. Okay, it has curves, therefore it's nonlinear. So if something has a curve to it, okay, it's nonlinear. Now it may not always have curves. Okay, for example, some of you, if I drew this graph right here, this might confuse some of you on linear and nonlinear. You may say, Mr. Reed, that's two straight lines. That's linear. There's no curves in that. Yeah, there's no curves. However, this is not a straight line. Okay? This graph right here has a stopping point and goes another direction. Okay? Do you remember so that right there would be nonlinear. Okay? It's chopped, it changes direction. Okay? So if it has curves or it has a change of direction, all right, it is nonlinear. Now, what's the equation look like? So let's think about this for a second. For linear, I said that we couldn't have no exponents. Okay. The equation on this portion, this has exponents. Okay, exponents. I think I spelled that wrong. No, I didn't. This has exponents. Okay, so that equation would look something like this: y equals 3x squared plus 7. Notice the exponent on the variable. This right here tells me, yes, this is nonlinear. Okay, so that exponent alone lets me know this is nonlinear. Okay, so if I gave you an equation, as soon as you see that exponent with that variable, nonlinear. Okay, or if I give you a graph, as soon as you see the curve of the change of direction, it's nonlinear. All right.